Greeting of the day. Welcome back to another video on generating function. In the previous video lecture, we have seen how to solve a recurrence relation using generating function. Here in this video lecture, I shall discuss one more example on solving recurrence relation by using generating function. So let's start. So question is solve using generating function. So function given is recurrence relation given is an plus 2 minus 2 times an plus 1 plus an is equal to 2 raised to n. A0 is given as 2 and a1 is given as 1. So obviously as we are going to solve this by generating function, so let g of x be the generating function of the form an x to the power n takes the value from 0 to infinity. That is g of x is a0 plus a1x plus a2x square and so on. Let us call the given recurrence relation by 1 and this is 2. Now observe here the lowest augmented term. Lowest augmented term is n. And to use the initial condition a0, we have to equate this lowest augmented term with 0. So n must be equal to 0. So what do we do? So we have to obtain this type of function an x to the power n here. So multiplying equation 1 by x to the power n and taking the sum. Now the sum runs over what? So as lowest augmented term is n, initial condition is 0, so n is equal to 0. So sum should run from 0 to infinity. So taking the sum from 0 to infinity, we get. So this will become summation n equal to 0 to infinity an plus 2 x to the power n multiplying by x to the power n and sum minus 2 being a constant, take it outside. Again summation from n equal to 0 to infinity n plus 1 x to the power n, then plus summation an x to the power n is equal to 0 to infinity is equal to summation, again multiply this by x to the power n, sum from 0 to infinity. Now after this, let's apply the sum here. So when we apply the sum here, as that is putting n equal to 0, 1, 2, 3 and so on, what do we get? In the very first term, we get when we put n equal to 0 here, so what is the first term? a2 x to the power 0. So it is a2 into x to the power 0 is 1. So it is only a2. So we have a2. Then when we put n equal to 1, we have a3 into x, n equal to 3, 2, it is a4 into x square and so on, will be the first term. Next, c minus 2, put n equal to 0 here. So a1 into x to the power 0 is 1. So a1 only. So it is minus 2 a1. Then when we put n equal to 1, we get a2 x, then a3 x square likewise. Let's see this one. So here we have put n equal to 0. So we know that this is nothing but what? As per notation, this is nothing but g of x. So we can replace this by g of x as well here. So this is plus g of x is equal to. Now, what about the right hand side? So put n equal to 0. 2 raised to 0 is 1. X to the power 0 is 1. 1 into 1, 1. So the very first term is 1. The second term will be 2 into x. So we have 1 plus 2x plus 2x square and so on. Or else, what is the next step? Another step for this. So you can see this is the generating function, right? This is the generating function wherein the general term, here general term is what? It is in the form 2 raised to n. So its corresponding generating function as per this formula, what it should be? 1 upon 1 minus ax. What is the value of a? A is nothing but 2. So we can write directly for this 1 upon 1 minus 2x as the generating function. Or else you can write it like this likewise, and then you can get the same formula. So now you can see the first term. As per the requirement, the term should be a0 plus a1x plus a2x square is required. So here a2x square is required, x square is missing. So what do? So we will multiply this complete term by x square as well as divide. So we have this as, it is a2 x square plus a3 x cube plus and so on. And at the same time, this gets divided by x square, multiplying and dividing by x square, minus 2 times. Now see here, a1 is there, so power of x must be 1. Again, a1 x is missing. So multiply this entire term by x as well as divide. At the same time, we want a0 here, right? Or let us do multiplication. So a1x plus a2 x square and so on, done, upon x. Then plus we have g of x, and if you do not remember the formula, if you are unable to apply this formula here in this case, then this is nothing but infinite geometric series. Infinite geometric series with first term 1 and common ratio 2x. Common ratio is 2x. Now, as per the requirement, the generating function must be a0 plus a1x and so on. So what is missing here? a0 and a1x is missing. So adding and subtracting a0 and a1. So it is a0 plus a1x plus rest of the term as it is, that is a2 x square plus a3 x cube and so on, and then this extra term will be subtracted as well. So minus a0 minus a1x. So this is my first term, and this complete term is divided by x square minus 2 times. Again, what is missing? a0 is missing. So we add a0 as well as subtract and divide by x to the complete term. So this is second term plus g of x, and as per the formula of sum of geometric series, we have formula as a upon 1 minus r. Here a is 1 whereas r is 2x. So it is 1 upon 1 minus 2x. Now this is as per notation g of x. So replace this by g of x. At the same time, use the initial condition. The initial conditions given are a0 is 2 and a1 is 1. So substitute it here. So this implies g of x minus a0 is 2 minus a1 times x upon x square. Then we have minus 2 times, again we have g of x. You can see this is g of x. This complete term is g of x minus a0. So again substitute the value of a0 upon x. This is g of x minus a0 is 2 upon x. Then plus g of x is equal to 1 upon 1 minus 2x. Now this implies, collect the term of g of x here. So therefore g of x is nothing but, here what is remaining, 1 by x square. Here in this case it's minus 2 by x plus 1. Now what are the remaining terms? That should be shifted on right hand side. Remaining terms are, so it is equal to 1 upon 1 minus 2x. Here what is remaining term? Minus 2 by x square. So it is plus 2 by x square. Then it is minus x by x square is minus 1 by x. So it is plus 1 by x. Next minus minus plus 4 by x. So it is minus 4 by x. So these are the extra term which are shifted on the right hand side. Now this implies, just take the LCM and try to simplify this. So this will become, LCM is x square. So it is 1 minus 2x plus x square equal to, what do we have? 1 upon 1 minus 2x, then plus 2 by x square, and then 1 by x minus 4 by x is minus 3 by x. Now let's take this complete term on the right hand side. So we have this implies, now you can see here 1 minus 2x plus x square is nothing but 1 minus x whole square. So we write it as 1 minus x whole square upon x square equal to, it is 1 upon 1 minus 2x plus 2 by x square minus 3 by x. Now after this, what do we do here? Now, so therefore dividing by 1 minus x square upon x square. So we have this as, this implies g of x, taking only, retaining only g of x on the left hand side. So we have very first term is 1 upon 1 minus 2x into, it will be, so it is x square upon 1 minus 2x into 1 minus x square, x whole square. Next is 2, x square will go here, so it will be x square cancel. It is 2 upon plus 2 upon 1 minus x whole square. The next term will be minus 3x upon 1 minus x whole square. Now you can see here in the second term and third term, 2 upon 1 minus x whole square. This fits over here in the formula. So you can see this is nothing but, this should be 2 only. So this is nothing but the generating function of the sequence whose general term is k plus 1 into k plus 2. Here the term is nothing but, in place of k what we have, n. So answer for this is n plus 1 into n plus 2 as per this table. As per this table, what it is? 1 minus x whole square. So as per this table, this is nothing but k plus 1. That is n plus 1. In place of n, k we have n plus 1. And 2 being a constant, so as it is. Again, see this formula. It is x upon 1 minus x whole square. So as per this, it will come out to be n here. So for second and third term, we have the formula in the list. Now what about this? So this is to be fitted in the list of formulae. As per the list, we will have to fit. So for this, we have to apply the partial fraction method. Let us call it as 2. And we will write this into a partial fraction by partial fraction method. So consider the first term only, as second and third term are as per the requirement. So consider x square upon 1 minus 2x into 1 minus x whole square. Now here you can see that this is nothing but the, after using the partial fraction method, we get this is nothing but equal to a upon 1 minus 2x plus b upon 1 minus x and then plus c upon 1 minus x whole square as per the partial fraction method. Here this is linear repeated. So what do we write? B upon 1 minus x till we get 1 minus x to the power 2. And this is linear distinct factor. Now, so while applying the method of partial fraction, we have this as x square equal to this will be a into a will get multiplied with, now the denominator should be this one. This already have 1 minus 2x, so a will get multiplied with 1 minus x whole square. Then plus b has 1 minus x, so what is missing? 1 minus x into 1 minus 2x. Then plus c has 1 minus x whole square already. So the missing term is 1 minus 2x only. Now then simplify this the way we have simplified in the previous example and equating coefficients of like power of x. So we get, so this step I am skipping here as you are already aware of partial fraction method. So we get a is equal to 1, b is equal to 0 and c is equal to minus 1. Substituting this here in this equation. So therefore, x square upon 1 minus 2x into 1 minus x whole square is nothing but equal to 1 upon 1 minus 2x minus 1 upon 1 minus x whole square. Using this in equation 2. So 2 implies g of x is equal to. So g of x is equal to, we have 2 upon 1 minus x whole square then minus 3x upon 1 minus x whole square, then this value, that is plus 1 upon 1 minus 2x minus 1 minus x whole square. Now what is the general term of g of x? So general term of g of x is an is equal to. Now what will be the general term of this? So look for 1 upon 1 minus x whole square. Here we have 2 being a constant, so 2 as it is, and the general term of 1 upon 1 minus x whole square is n minus 1. Here we have used the symbol n. So it will be n plus 1. Then minus 3. Then for x upon x minus 1 minus x whole square we have n only. So 3 being a constant as it is, and here 1 upon 1 minus 2x. This fits in this formula. A is nothing but 2. So as per this, general term is 2 raised to n minus. Again 1 upon 1 minus x whole square gives you n plus 1. Now simplify. So what do we have? So this is equal to. This is equal to so it is 2 raised to n. Then 2n minus 3n is minus n minus n. So minus 2n. And then what is remaining? Plus 2 minus 1. So that is plus 1. So an is equal to this is the required solution. So in the next video lecture we shall see one more example on solution of recurrence relation using generating function. Thank you all for watching the video.